Today we are starting about acid bases and how we can prepare some soluble and insoluble salts. So to make the salts, first of all, we need some solubility rules to understand. Only then we can make some soluble salts and some insoluble salts as well. Okay. Before that, so far we have did about acids and bases and their definitions as well according to the pH values, right? So today we are going to extend this definition about acid and bases, and then we are going to prepare the soluble and insoluble salts. Okay, let me ask you guys, first of all, before starting the solubility rules, whatever you guys know about acid and base, how we can define an acid and how we can define a base. Raise your hand if you know anything about the definition of acid and base. Okay, we have Mariam. Yes, Mariam?
Miss, I think that acid is a proton acceptor and base is a proton donor.
Okay. Okay, not this definition. Whatever definition you have done before, according to pH values. Can you tell me the definition of acid and base according to pH values? Which one is going to have what value of the pH? Less than 7, more than 7, equal to 7? Yes, Samreen.
Miss, acids will have a pH less than 7 and bases will have the pH more than 7.
Right. This is the definition we did before. You have done this in grade 8 as well, that the acid basically have the pH value less than 7 and the bases have the pH value more than 7. And if the pH is equal to 7, then it is going to be something neutral, like water. Water has the pH
Neutral,
equal to 7.
which is water.
Yes, Luna.
Yeah.
Yes, Luna, you want to say something?
Oh no, Miss.
Okay.
I was about to answer.
So this was the old definition we did in grade 8, and now we are going to extend this definition about the acid and base. Okay. Because in chemical reactions, in chemical equations, we will not be able to check the pH value every time to identify if something is acid or base. Now we can add something about proton. So there is one proton we have studied in the atomic structure, that is like the particle present at the center with positive charge. Same way, now we are going to add another definition of the proton as well. Proton is something having positive charge. So H having positive charge is known as proton. So any compound which can donate the proton will be known as acid. So acids will be known as proton donors. In other words, they can donate H positive ion. And any compound which can accept the proton will be known as proton acceptor or base or alkali. Okay. So proton acceptors will be known as alkali over here. So if we take an example of very regular and simple acid, hydrochloric acid, HCl, it has hydrogen inside. So means it can easily donate this hydrogen in the form of H positive when we write a chemical equation. Okay. So it is giving out in the product side this H positive ion, means it is proton donor. So this HCl, which is donating this proton, is basically known as acid. Same way, we can talk about bases or alkali. For the bases and alkali, I will even extend this definition little more. Bases or alkali are basically those compounds or species, number one, that we said already, that they have pH more than 7, right? Number two, they can accept proton. So they are proton or H positive acceptors. There is another definition for them as well, which will be more easy for you to identify in chemical reaction, and that is they can donate hydroxide ion. What is hydroxide ion? Who can tell me the formula of hydroxide ion quickly? Okay. Yes, Wafia.
Miss, OH minus.
OH minus. They can donate OH minus ion or hydroxide ion. Okay. So now let's take the example. We can apply any of these definitions wherever it is applicable. For example, if you check out NaOH, you want to see if this NaOH is an acid or alkali. So what you can do, you can see it has OH inside. So in a chemical reaction, it can easily donate this OH. So yes, Donation of OH is basically the nature of base or alkali. So like this, we can easily identify. So we can apply this proton acceptor definition as well. We will see some example where we can apply only proton acceptor definition. In some examples, we can apply donation of OH negative example. So both definitions will be applicable. Okay. So we have some questions here. Yes, Luna.
Miss, in the acid,
Hmm.
H plus, we already knew that it's a proton donors. Cl minus, is it an acceptor?
No. Cl minus is doing nothing here. Cl minus is a negative ion. Okay.
Oh,
That
so
will just make a
make it
salt.
a neutral.
That will
Just
just
to
make
make
a
it
salt. Yes.
Uh.
So basically, Cl negative will go and make a salt, and this H positive ion will remain over there. So we are going to just see that which species of the compound is going to donate H positive ion, that will be acid. And if it is donating OH negative ion, that is going to be alkali or base. Okay. There is a very common misconception here as well. Sometimes we consider the bases and alkali as the same thing. In exams, sometimes students write that the base has pH more than 7 or alkali has the pH more than 7. So we can use them anywhere. They are not same. They are different. We will also talk about the differences in the bases and alkali and where we can use them. Okay. So that was a basic introduction over here. Now we will go back to a table which has all the solubility rules that you have to remember word by word. Only then you will be able to make any kind of the salt. Okay. So according to the solubility rules, most of the ionic compounds, we have already done some of the ionic compounds and some of the covalent compounds as well in detail in many chapters. About the ionic compounds, because they have positive and negative both ions at a time, so they are most of the time soluble in water because of this positive negative ion as compared to covalent. Only some of the covalent substances will be soluble, maximum are insoluble. Okay. Maximum ionic compounds are soluble, except some. There are some exceptions as well. So what you can do, you can just remember those exceptions and remaining ionic compounds will be soluble. Okay. So let's see the table, which is a summary of all the solubility rules for the common salts. So salt made from sodium, potassium, and ammonium. Sodium salt means sodium chloride. Potassium salt means potassium chloride. Ammonium salt means ammonium chloride. Like any salt which contain metal, sodium, potassium, or maybe ammonium ion, all will be soluble. Okay, not a single is insoluble, all will be soluble. Okay, same way, if we talk about nitrates, we know what is the formula of nitrate ion. Anyone quickly? Nitrates. Okay, we have Wafi again, yes.
Miss NO3.
NO3. What charge?
Positive.
Nitrate. Luna, you want
negative.
to? Negative. How much negative? Negative?
3.
-3 on nitrate?
Wait, hold on.
Okay, think about it, Samreen. Yes.
Miss NO3 -1.
NO3 -1, perfect. It is NO3 with just -1 charge. So it can just make a bond with the positive one metal. Okay, so all the nitrate salts which has NO3 -1 inside are going to be soluble. Not a single is going to be insoluble. Same way, all the chlorides. Chloride means containing the Cl -1 charge. They most are soluble except 2. So here it is important to just remember these 2 exceptions. Silver chloride and lead 2 chloride will be insoluble. All remaining will be soluble. Okay. Then we have sulfates.
Soluble with any aqueous solution, right?
Soluble with water, yes. Here the solubility with water we are checking. Means can we make aqueous solution or no?
Yeah,
okay.
yeah. That's the
So sulfates. Now who can tell me quickly the formula of sulfate? We did all these formulas in complex ions.
SO4.
SO4 with what charge? Charge.
-2.
-2, perfect. SO4 -2 is going to be sulfate. So most of the sulfates are soluble. Only 3 are exceptions that you can remember. Barium, calcium, and lead. Okay, barium sulfate, calcium sulfate, lead sulfate. These will be insoluble, all other are soluble. Carbonates. For the carbonates, it means there will be what formula?
CO3.
What charge?
CO3.
CO3 -2.
-2, perfect. Carbonate means if they contain CO3 -2 inside, then these carbonates most are insoluble. Okay. Do you remember the example of calcium carbonate when we did the lime water carbon dioxide test? We said that
Yes.
Yes.
Mhm.
CaCO3.
ACO3, very good. So what we said that if we have lime water and we pass carbon dioxide from the lime water, what will be the product at the end? It was,
Wait, hold on.
if we pass the lime water from the carbon dioxide gas, if we mix them together,
Wait,
raise
hydrogen?
your hand only. Raise your hand only. We have, yes, Wafia.
Miss, a cloudy white precipitate.
It was causing white precipitate, or the solution was turning milky or cloudy, right? So it was basically making calcium carbonate in the form of solid in water. So that was one of the insoluble carbonate example, calcium carbonate in that carbon dioxide gas test. Okay. Then hydroxide again means the OH negative ions are present. So most of the hydroxide ions will be insoluble. Only the sodium, potassium, and ammonium will be soluble. And calcium hydroxide is slightly soluble in water. Okay, not much, just slightly soluble in water. So this table is basically, yes, Luna.
Sorry. But so sparingly means partially?
Slightly.
Oh, slightly.
Okay, sparingly means slightly soluble in water. Okay. So this table you have to learn, only then you can apply these rules in the whole chapter and easily you can make any kind of the salt. Okay. So let's move forward. We did the acid and base new definition according to the proton donor and acceptor. We are going to see some of the reactions of the acids. Okay. Acids can react with metals. For the metals, we did a reactivity series in which we said that hydrogen will be somewhere at the center and some metals will be above the hydrogen and some metals will be down the hydrogen. So the metals which are above the hydrogen, we know these are going to be the reactive metals, and the one which are going to be down, they are less reactive, and at the end there will be unreactive metals as well. Okay, if any metal has to react with acid, the metal should be above the hydrogen. So all the metals which are downward, they will not be able to react with hydrogen. So only those metals which are above hydrogen in the reactivity series will be able to react with acid. Okay. So again, they will react according to their reactivity series. More reactive metal is going to react fast. Vigorous reaction will happen. For example, at the top of the reactivity series, we have sodium and potassium, two reactive metals. If they will react with the acid, they will produce an explosive reaction. So very dangerous reaction will be there. So we cannot even try this kind of the reaction in the lab. So in the lab, if we want to perform any metal reaction with the acid, we are going to choose a moderate reactive metal, little above the hydrogen, but not very reactive at the top. Okay. So when the metal and acid are going to react, they are going to produce one salt and hydrogen as the product. Why we are getting a salt and hydrogen? For this, we can see some examples as well. Let's say we are going to take metal magnesium. We want to react it with the sulfuric acid. It is producing salt MgSO4 over here. Why MgSO4 salt is produced over here? Anyone? Why we are getting
Miss, we said,
yes.
Miss, we said we put the salt with the metal or the most strongest, most reactive one. So it will make a magnesium sulfate, and the hydrogen, which is the less reactive one, will be left behind.
Right, that is fine. So here basically we can easily apply the displacement reaction as well. Means replacement. More reactive can come and replace or displace the less reactive one. That is very important board question as well. They can ask you the reason that I just told you, that all the metals which are above the reactivity series will react. Okay, fine. But if they ask you in the exam, why? Why only the metals above hydrogen are reacting with the acid, not below hydrogen? And the Luna just told you half of the answer for this, and that is basically the displacement rule. Okay, magnesium is more reactive, so if metal will be more reactive, only then this metal can come and replace this hydrogen from here. If metal will be less reactive, it will not be able to replace hydrogen. Reaction will not be possible. So metal should be more reactive than hydrogen so that it can remove this hydrogen from the formula of acid and make a salt. Okay, so these are some of the examples for the zinc metal, for the iron metal. All will follow the same rule, same sequence, and same equation will be there. Right after writing the equation, you are going to balance the equation as well. And we did the balancing equation to balance all the atoms on the reactant and the product side. Okay, so when they are going to react with sulfuric acid, H2SO4 is sulfuric acid, right? What salt they are producing over here? And when they are reacting with hydrochloric acid, what salt they are producing over here? Who can tell me?
Miss, with
Raise
sulfuric
your
acid,
hand.
it's called sulfates.
Yes, Mariam Mahmood. Raise your hand
Miss,
and answer. Yes, Mariam.
okay. When they react with sulfuric acid, they produce sulfates. The salts
Very
are called
good.
sulfates, but with hydrochloric acid, they are called chlorides.
Right.
Yes.
So when they are going to react, basically the acid is telling you the name of the salt produced. When the metal is reacting with sulfuric acid, means SO4 is there. So sulfate containing SO4 will be produced. And when they are reacting with the hydrochloric acid with Cl, so chloride containing Cl will be produced. Okay. After that, there is a table. Here I am going to ask you another exam question. How they can ask you the question in the exam? They can give you this equation. Okay. Metal, you know, in the exam, they will never ask you the straight question, straight definition, straight equation. They can ask you something, a twisted question. They can give you this equation and they can ask you, okay, what metal we can use over here? Which group metal we can use over here? Group 1 from the periodic table, group 2, group 3. Which group metal we can use in this specific equation? Think about it and try to answer.
Miss, so
No.
they won't ask us to specify a specific element because
No. They will not ask you because you cannot identify the metal without performing experiment in the lab. But you can identify the group of the metal. Which group metal will be reacting in this specific equation? Yes, Wafia.
Miss, I think for here we're going to need a metal that can take 2 electrons from chlorine.
Okay.
So
which group metal it will be? Think about it. Just apply your group and the charge concept over here.
one second.
And then try to see. Yes, Samreen.
Miss, can it be group 2? Because like the group 2 and
Miss, I was going to say
if group 2, then
group
what is the reason?
6.
Like why group 2?
because with group 2 they can lose the electrons and then the chlorine can gain the electrons, 2 electrons, right?
Oh yeah.
That's right. Yes, perfect, Samreen. So it is going to be group 2 because we know that the group 2 metals can lose 2 electrons and group 2 metals can have the charge +2. If you see this MCl2 formula, in this MCl2 formula, you have 2 chlorines, Cl2. It means the chlorine has -2 charge. Then the metal M should have +2 charge to balance it. And +2 charge means group 2 metal. Got it? Same way.
Miss, I have one question.
Yes.
Miss, if we use the group 2 metals, they're going to lose both their electrons.
So yes, they are going to lose both their electrons.
Oh wait, never mind.
Not losing. Ionic compounds are formed means they're sharing the electron, they're transferring the electron. Okay. So from the metal, the electron is going to the chlorine, right?
Yeah.
If we have, let's say, group 2 metal magnesium, suppose any group 2 metal, and we have 2 chlorines over here. So yes, one magnesium will lose 2 electrons. 2 electrons will transfer from magnesium to chlorine. 2 electrons will go, right? So the same concept we can apply over here. So this is a very common exam question again. I can give you another formula so you can quickly tell me. Let's say we have a metal with formula MCl3. In MCl3, which group metal is reacting now?
Group 3.
Group 3, because 3 chlorines are going to have charge -3, and this metal should have +3 to balance it. So easily by checking the formula, we can see which group metal is participating in the specific equation. Okay, clear? Okay, after that, let's move forward. Reaction of the acid with bases. Acid can react with the base and they can do the neutralization reaction. I hope you have studied about the neutralization before as well in grade 8. Now we will see some of the detail of this neutralization. So acid-base react, they will produce something neutral. Why we said neutralization reaction? Because neutral product is produced at the end. Salt and water.
Miss, we can say that both of them cancel out each other.
Both of them cancel out each other. That is fine. Salt and water basically both have pH 7. So means neutral products are produced. pH is 7 for salt and water. So neutral products are produced. So it means it is going to be a neutral solution and neutralization reaction. Okay. So after that, let's check out some examples here.
Miss, I have a question.
Yes, sure.
So salt, is it a base or an acid?
The salt is a base or acid? It depends. We will check. Right now, salt is not a base or acid here. Salt is having pH 7. Most of the salt have the pH 7. So they will be not acid, not base. They will behave like neutral. Okay. Okay, so let's check out some of the examples for the neutralization reaction. Whatever salt is produced, we can easily check out the acid and it will tell us like the hydrochloric acid produce the chlorides, sulfuric acid produce the sulfates, nitric acid produce nitrates. So metal oxides, some of the metal oxides basically like metal oxide and metal hydroxide, they behave like bases. So if we take metal oxide or hydroxide, they can react with acid and they can produce a salt and water. Here like HCl is behaving like an acid. Copper oxide, CuO, is basically a metal oxide. Oxide means having O. Hydroxide means having OH. Okay. So acid and metal oxide is reacting, producing copper chloride salt with water. Same way, if you check out the second equation, in the second equation, H2SO4 is acid. It is reacting with NaOH. Now, NaOH is metal hydroxide because it has OH inside. Metal hydroxide means sodium hydroxide. Like this, you can remember the names. So it is producing Na2SO4, which is salt with water. Then we have HNO3 nitric acid. It is reacting with KOH. OH means hydroxide. K means potassium. So potassium hydroxide is making potassium nitrate salt with water. Okay, so like this, we have some of the neutralization reactions. Yes.
Miss, wouldn't the acid HNO3 where the potassium hydroxide be very dangerous? Like
potassium hydroxide will be dangerous. See, the alkali or the bases are basically not dangerous if we just make their aqueous solution. They will be corrosive in nature. Corrosive means they can give you itching and some little burning on your skin. But if you just try to use them carefully in the lab by putting some gloves, then it will not do anything. You can easily do the reaction in the lab. Okay, so
no,
they are just
when it reacted with the acid, wouldn't it be a reactive and explosive and those kind of things, or no?
Potassium hydroxide, no. That is basically when we have pure potassium metal.
Oh, okay.
Simple metal, that is an explosive reaction. That will have explosive reaction. In case of potassium hydroxide and making its aqueous solution in water will be light, very light solution. It means it is not dangerous. Simple metal of potassium sodium will be dangerous. Okay?
So, Miss, can we do these in lab or not?
Definitely, we will be doing this in lab. These are easily doable reactions. Okay? Okay, so then
Miss,
there is a table as well with some more examples. Yes, Wafia, your question?
Miss, will any of these reactions have anything to do with like electron transfer, whatever that we need to know?
Yes. Right now, we are not doing those in this example, but you can apply as well. If they ask you that any of this reaction is a redox or no, what you can do? You can easily check out their oxidation numbers. They are changing or no. Which one is increasing oxidation number, which one is decreasing, and you can identify the same thing we did, their oxidation numbers. Yes, Luna.
Oh no, Miss, nothing.
Okay.
I just
So oxidation number you can apply in any type of the equation. If they ask you to tell which one is acid or base, which one is more reactive, less reactive, which one is doing oxidation reduction, easily apply the oxidation numbers as well. Okay.
Okay, Miss.
Okay. After that, acid can also react with metal carbonates. For the carbonates, they are going to produce 3 products now, not 2. Salt, carbon dioxide, and water. Carbon dioxide is the extra product here because the carbonates always give out carbon dioxide. So carbon dioxide gas will be produced in the form of bubbles. So effervescence or bubbles will be there. So you can write effervescence will be seen as an indication or observation. If they ask you in the exam that when metal carbonate react with acid, what is the observation? In observation, if you say that salt, water, carbon dioxide is produced, no marks. Okay. Again, I'm repeating my question. Question is, if they ask you in the exam that when acid react with the metal carbonate, what is the observation in the reaction? If you are writing the products, the product is salt, carbon dioxide, water, they will not give you any type of the mark. Observation means what we can see. We cannot see salt, we cannot see water, we cannot see carbon dioxide. Mixed thing, how we can say it's water? It can be anything. We can see bubbles of the gas. So observation will be bubbling, effervescence will be seen. So you will write this answer as a observation. Yes.
Miss, effervescence is bubbles, meaning?
Yes, bubbles. Effervescence means bubbles of the gas.
Okay, Miss.
So you can write effervescence word, you can write bubbles as well. Both will be correct. So bubbles will be seen for the gas. That will be your observation for the exam. Okay. Then we have some more examples over here that when hydrochloric acid react with metal carbonate, it produces the metal chloride, carbon dioxide and water. Sulfuric acid will be there, so it will produce metal sulfate, carbon dioxide, water. Carbon dioxide water is a common product in all. Only the salt name will change according to what acid we are using. Okay. Yes, Varif.
Miss, I didn't hear the answer that you said about Luna's question. That effervescence is like bubbles or not? Like they're the same meaning?
Yeah.
Yeah, effervescence. Yes, effervescence means bubbles of the gas.
Oh, okay, thank
So
you.
you can write effervescence in the exam. You can write bubbles as well. Okay. Both fate will be correct. Or you can even write gas will be produced. So that is also the same thing, that gas bubbles will be visible to you as an observation. Okay. So these are the symbol equations when acid react with metal carbonate, produce salt, water, carbon dioxide. Write the equation, balance out on both sides, so it will be done. Okay, so sometime in the exam, they can ask you as well that there was an acid, it was reacting with base, it produced some product, okay? But there was effervescence or gas produced. So what can be the base identity? So question is, they're telling you there is an acid, it is reacting with something base, doing a neutralization reaction, producing a gas, water, and salt. They're not telling you the name of the gas. They're just telling you there is a gas. From this gas, you have to identify what can be the base over here. Anyone who got my question? What can be the base over here? So possibilities of the
Miss,
base. Let me give you the possibilities. We just said that the base can be, over here we said that base can be metal oxide, metal hydroxide, or metal carbonate. This base possibility is only three. Only three are in your exam. It can be metal oxide reacting with acid. It can be metal hydroxide reacting with acid and producing a gas. Or it can be metal carbonate reacting with acid and producing a gas as well. So,
Miss,
which one is possible? Yes,
may
Varif.
I-
Raise your hand,
Miss,
Varif.
metal carbonate.
Metal carbonate. Because for the metal oxide, we said that when metal oxide react with acid, they just produce salt and water, no gas. They both just produce salt and water. This one also produces just salt and water. But the metal carbonate is producing salt, water, and carbon dioxide gas as well. Okay? So this gas is definitely a carbon dioxide gas. They can ask you identity of the gas as well, that there is an acid which is reacting with base and producing a gas. What can be gas? There is only one gas when acid-base react, that is carbon dioxide gas.
Carbon dioxide.
So these are some general questions, but they will ask you like twisted one, little critical thinking, but easy questions. Okay. Okay, let's move forward after that. Let's talk about some bases. When we are saying that we have a base, why a base act like a base? So basically over here term, the base and alkali are not same, they are different terms. Who can tell me if you already know? What is the difference between base and alkali? Okay. Mariam?
Yes, miss. Bases are metal oxides or metal hydroxides, but alkalis are bases, but they are dissolved in water. They dissolve in water. That's the
Okay,
difference.
that's right. That is right definition, Luna.
Oh no, Miss, I have no idea.
Okay. Okay. So basically the base and alkali both will be having pH more than 7. But the difference is their solubility. The alkali are soluble bases. Okay. Bases, alkali, both are bases basically. But alkali is a small term. Base is a general term. Base is everything having pH more than 7. It can donate hydroxide ions or it can accept proton, whatever definition we said, all apply to the base. But alkali are a part or a group of base which is soluble in water. So only soluble in water bases are known as alkali. Okay. So a base which is water soluble is known as alkali. So all the alkalis are bases, but all the bases are not alkali. Because all the bases are not soluble in water, so all the bases are not alkali. This statement is clear to everyone? That all the
Miss,
alkalis are bases, but all the bases are not alkali because all the bases are not soluble in water. Yes.
Miss, so basically the before statement, base is soluble in water or alkali?
Alkali is soluble in water.
Okay, alkali.
So alkali is a part. Let's say if I make a circle and I say all the bases come in this circle. But there is a small circle inside which is containing just alkalis. And these alkalis are water soluble. Okay. So now we can apply the same statement that all alkalis are inside the base circle, but the bases are not inside the alkali circle. Getting the point? Now it will be clear to you that all the alkalis are bases, but all the bases which are outside this small circle, they are not inside the alkali. So all the bases are not alkali because they are not soluble in water.